Quadratic equations. This topic is on the easier side, so even average students can easily handle this. You need not worry about it. We can expect one question in section A for 3 to 4 marks and one word problem in section B for say 4 marks. Okay. Now we will have a quick understanding as to what is a quadratic equation. Any equation of the type ax square plus bx plus c equaling 0 is a quadratic equation in x. Note x is a variable here. X is a variable. A, b and c are constants. Highest power of x is 2. Highest power of x is 2. So therefore we call this as a quadratic equation. However, there is a condition that a should not be 0. Why? Because if a becomes 0, you will have 0x square. So then the square term vanishes. 0 into x square is 0. Okay? So x square term will vanish. Then how will it become a quadratic equation? So a should not be 0. However, there is no condition on b or c. So if we have say c is 0, it is not existing. We can have something like ax square plus bx equaling 0. Even this is a quadratic equation. Look at this, ax square equaling 0. Even this will be a quadratic equation. So what is important to notice that the coefficient of the square term should not be 0. So these are all different examples of quadratic equations. Consider x minus 1 upon x is 7. Do you feel it is a quadratic equation? At the outset we feel no. Where is the power 2? Highest variable, where is it 2? But let's simplify this. LCM will be x here. So here we will get x square minus 1 is equaling 7. X square minus 1 is equaling 7x. So x square minus 7x minus 1 equaling 0. And now is it quadratic? Yes. So this was also a quadratic equation, but it was in a disguised form. Okay. After a bit of simplification and trying to put it in the standard form, we realize that this equation is definitely a quadratic equation. Now this much introduction was sufficient. Now let us come to the main thing, how to solve quadratic equations. Now in our syllabus there are two ways in which we can solve a quadratic equation. One is by factorization technique, that is quadratic trinomial splitting, or by formula method. So let us first take say two sums on factorization technique. 2x minus 3 the whole square is equaling 49. We need to find the value of x, or the question can also be framed, find the roots of the equation. Roots of the equation means finding that value of x or y or any variable which is used which will satisfy the given equation. Okay. First you may feel that you can open up the brackets using a minus b the whole square, which is perfectly fine. It is not a wrong technique, but we have a little better technique. We can say that 2x minus 3 will be square root of 49. Square root of 49 will be plus or minus 7. That is most important here. Now, square root of any number, say square root of 64 can be 8, square root of 64 can also be minus 8, no problem. So, two possibilities arise. 2x minus 3 will be 7, or 2x minus 3 will be minus 7. Come here, so 2x will be 10 after you transpose, x will be 10 upon 2, that is 5. So x is 5. Here 2x will be minus 7 plus 3 equaling minus 4. So x will be minus 4 upon 2, which is minus 2. So there are two possible answers. Either x can be 5 or x can be minus 2. No need to write solution set from the exam viewpoint. No marks are reserved for it. You can leave the answer at this stage. Absolutely no problem. Now let us take one more sum, which is based on factorization. Consider 2x minus 3 upon x minus 1 minus 4 times of x minus 1 upon 2x minus 3 equaling 3. Do not be in a haste and just open up the brackets. Use power of observation. This term is a reciprocal of this. Same term is repeating here, but it is a reciprocal. So it is better to go by substitution technique here. It saves a lot of labor. Put 2x minus 3 upon x minus 1 as a. Use any variable which is not used in the question. So what will happen is we will get a, this whole body is a, minus 4 times of, what will be this? 1 upon a. Why? Because if this is a and here we have taken the reciprocal, so won't it be 1 upon a? Is equaling 3. So we will get a minus 4 upon a is equaling 3. Now we will have to solve this. So it was a minus 4 upon a is equaling 3. So let's take the LCM. You will get a square minus 4 is equaling 3. A square minus 4, a into 3 is equaling 3a. So a square minus 3a minus 4 is equaling 0. Always remember to put the quadratic equation in the standard form, else you will go wrong in splitting and further solving. First the square term, then the middle term in which the variable repeats again, and then finally the constant term without any power of a. Keep all the terms on the left hand side and the right hand side you keep it as 0. Okay. Now what is coefficient of a square? 1. Constant term is minus 4. So 1 into minus 4. Remember, that is minus 4. So this can be done as 1 minus 4. The two factors, signs are important. 1 minus 4 is minus 3. 1 into minus 4 is minus 4. So both the conditions have been taken care of. So we have a square plus a minus 4a minus 4 equaling 0. Now what will you do? Routine factorization. A into a plus 1 minus 4 can be taken common into a plus 1 equaling 0. We have a plus 1 common into a minus 4 is 0. Now observe that product of two numbers is 0. If product of two numbers is 0, one of them will naturally be 0. Right? If product of two numbers is 0, then one of them has to be 0. So a plus 1 is 0 or a minus 4 is 0. So here a will be minus 1 or a will be 4. Remember, these are not our final answers. Remember to resubstitute. What was A? We had taken A as 2x minus 3 upon x minus 1. This is what we had taken as A. So let it bring it back. So this will equal minus 1. Same thing happens here, 2x minus 3 upon x minus 1 equaling 4. Now you cross multiply, you will have 2x minus 3 is minus x plus 1. Take care of the signs. Transpose, 3x will equal 4, x will equal 4 by 3, which you can keep it like this in this topic of equations, or you could write it as a mixed fraction 1 by 3. Better. Here also you cross multiply, routine equation solving, 4x minus 4. So 4x you bring on this side, minus 2x is minus 4 plus 3. So minus 2x will be minus 1. So 2x will be 1. So x will be half. So there are two solutions. X is either 4 by 3 or x is half. No need to write the solution set. We can safely leave it at this stage. A typical 4 marks sum. Question 3. K plus 2 times x square minus kx plus 6 equaling 0. This is a given equation. It is also said that if 3 is a root, of this equation, find k and also the other root. Root means solution. So equation is k plus 2 times x square. So k plus 2 acts as a single gatha, single entity, minus kx plus 6 equaling 0. So it is very clear that this equation is quadratic in x power 2. Then power of x is 1 and then the power of x disappears. It is told to you that 3 is a root of the equation. 3 is a root of the equation. So now we have to find k, and after that we also have to find the other root of this equation, because quadratic equation will have two roots. So we need to find that other root also. So let us see how to proceed. Solution. As 3 is already a root of the equation, it will satisfy the equation once I substitute it here. So we will say k plus 2 times, put x as 3. Why x as 3? K we cannot put 3. The value of k has to be found out. Okay, and it is a quadratic in x, and 3 is a root of that equation. So k plus 2 times of 3 square minus k into 3 plus 6 equaling 0. For sure, when I put x as 3, equation is bound to get satisfied, as 3 is already given to be one of the roots. Simplify. 3 square is 9, 9 into k. This substitution is very important from the exam viewpoint. This step will carry 1 marks. Later on, if you do some calculations mentally, absolutely no problem, but substitution has to be shown. This will be 9k plus 18 minus 3k plus 6 equaling 0. So 6k plus 24 equaling 0. So 24 will go on that side, 6k is minus 24, k will be minus 24 divided by 6. So how much is that? K is minus 4. Why I am putting a negative number in bracket? Because otherwise equal to sign and negative will come very close to each other, making it look very odd. So it is always advisable to put a negative number in such cases in brackets. So k is 4. Now this has been done, but we need to find the other root. Problem is not yet over. So remember, k is now minus 4. So we will have to substitute k as minus 4 here to get the complete quadratic equation. So minus 4 plus 2 x square. This minus comes because of this, and k itself was minus 4. Take care. Plus 6 equaling 0. And this will be minus 2x square plus 4x plus 6 equaling 0. We can change the signs throughout to make things comfortable, else we can work with this also. So it will be 2x square, so that the square term is positive. 2x square minus 4x minus 6 equaling 0. We can easily factorize this, but we can still divide this equation by 2 throughout. So have this habit, whenever you have an equation which has got scope for some simplification, to make it smaller, do that. Here I can divide each and every term by 2. That is the highest common factor. So I can divide each and every term by 2. So this will become x square minus 2x minus 3 equaling 0. Is it in the standard form? Yes. Square term first, then the power of x is 1, and then the power of x disappears. Okay, what is the coefficient of x square? 1. 1 into minus 3, minus 3. So split factors would be 1 and minus 3. 1 minus 3 is minus 2. 1 into minus 3 is minus 3. So both the conditions are taken care of. So now, so remember, it is 1 and minus 3. So it will be x square plus x minus 3x minus 3 equaling 0. So you will have x into x plus 1, minus 3 is common. Take first and second term, third and fourth term. So x plus 1 into x minus 3 is 0. Same, product of two numbers is 0, so either of them will be 0. So x plus 1 is 0, or x minus 3 is 0. X is minus 1 or x is 3. Is the sum over? No. What had the question asked us? And also find the other root. 3 was already given. 3 is a root. 3 was already given to be a root, which has now reflected in our solution. So which is the other root? Minus 1. So we will have to write that statement. Therefore, even if you don't write therefore, it's okay, but the final step you will have to write, because the question says find the other root. So 3 was already a root. So other root is minus 1. This step would be definitely important, as it shows that you have comprehended the problem. So the other root is minus 1. Now we studied certain sums based on factorization technique. Hope you are comfortable with the same. So now let us come to comparatively more important, solving a quadratic equation by formula. Normally in the board, it is not specified solve by formula. Normally it is not specified. You will have to understand that this problem is based on formula. How? If the equation is not factorizable, then you should use the formula. But take care that even if factorization technique is applicable, and if you still want to use the formula method, absolutely no problem. Formula method is a very general method of solving a sum. It can be used even for those cases where you are unable to factorize and proceed further. So this is much more important than factorization. But knowledge of factorization was very essential, so I had to take about 3 sums. Okay, you definitely can get sums in the board exam based on factorization. Now let us come to formula. Consider the sum 5a into a plus 2 is equaling 3. We will have to simplify this, bring the equation in the standard form, and then solve. The question says solve for a. This is the way question will be framed. Solve for a. Or they can say find the roots of this given equation. Now 5a square, open up the brackets, plus 10a equaling 3. Transpose, keep everything on the left hand side and the number 0 on the right hand side. So 5a square plus 10a minus 3 equaling 0. Now you have to compare this with the standard form, ax square plus bx plus c equaling 0. So is it arranged properly? Yes, first the square term, then the power of a is 1, and then the power of a disappears. Please note, it is not necessary that every time the equation will be framed in x or y. It can be framed in any variable p, q, r, why not? So here a will be 5. What does a stand for? Now be careful. What has happened is, since the original question uses a, we will not use a. We will use capital A. So capital A will be 5. So capital A will stand for the coefficient of the square term. Then B will be 10. That is the coefficient of the A term, middle term. Take care of the signs. And C would be the constant term, that is minus 3. Now we will solve by formula. This sum we will solve by formula. Because if you try to factorize this, it is not factorizable. If you want, we will try for a minute. 5, coefficient of a square 5, constant term is minus 3. 5 into minus 3, minus 15. Let's try splitting. What would be the factors? You can take 3 and minus 5. Let us see. 3 into minus 5, minus 15. Good. 3 minus 5, minus 2. What is here? Plus 10. Not okay. So you realize it is not possible here. The factorization technique will not work. Any combination you try. So we are forced to go by formula method. Now, small a equal to, if this equation was in x, we could have written x equal to, but this equation is in a, so small a equaling minus b plus or minus root of b square minus 4ac the whole divided by 2a. This is the formula. Minus b plus or minus square root of b square minus 4ac the whole divided by 2a. It is plus or minus because square root of a number will be plus or minus, so it is inbuilt in the formula. Remember this square root sign should be properly stretched over both these terms, else the meaning changes and you are bound to lose marks. Even this upon sign should be completely stretched. Consciously take care of these two things. Now let us substitute. Minus will come here. B is 10 plus or minus root of b square. Use brackets. It looks neater and easier to work on it. Minus 4 AC. A was 5. C was minus 3. The whole thing Square root sign properly stretched upon sign properly stretched upon 2a, 2 into 5. Now let us take it from here. So it will be minus 10 plus or minus square root of 10 square 100. Here be very careful in the signs. 4 into 5, 20. 20 into 3, 60. But this is negative, this is negative. Negative into negative, positive. So it is plus 60. The entire thing divided by 10. So minus 10 plus or minus square root of 160, the whole divided by 10. Now here comes the use of mathematical tables. So you have to keep in mind with you Cambridge Elementary Mathematical Tables by Miller and Powell. This book you need to have with you. Square root of 160, don't be in a hurry to find square root of 160. This can be easily split. So it will be minus 10 plus or minus square root of 16 into 10. This is the best possible splitting. The whole divided by 10. So it is minus 10 plus or minus. Now square root sign will operate independently on each and every term because there is a multiplication sign, or even if there was a division sign, square root will operate independently on both the terms. So this will become 4 root 10. The whole divided by 10. So minus 10 plus or minus 4 into root of 10. For this we will have to come to page 28, powers and factorials. You have to come to page 28, powers and factorials. There I presume that you know how to refer to these tables by this time. So square root of 10 is 3.162. We will take it as it is, no premature rounding off. 3.162. Entire thing divided by 10. So your 1 mark is for your substitution, what we did in the beginning, formula and substitution 1 mark. 1 mark is for your finding the square root, and 1 mark will be naturally for your final answer. So this would be minus 10 plus or minus 12.648 divided by 10. Now there are two possibilities, minus 10 plus 12.648 divided by 10, or minus 10 minus 12.648 divided by 10. I suggest you should do these addition subtractions actually and not go on the judgment, because sometimes the numbers can be so designed that you will strongly feel, oh, this thing is the answer, but it will not be that. It would be something different, and which you will get an idea only when you actually subtract and see. Now this is fairly easy, so it is okay, but still we will have that habit of actually subtracting. So this will be 12.648 minus 10. So it comes 2.648. Signs we will adjust. So it is positive, divided by 10. This will be minus 22.648 divided by 10. Dividing by 10 is simple. This will be 0.2648 or minus 2.2648. We cannot leave the answer like this. Remember, if the degree of accuracy is not specified for quadratic equation sums, then it is necessary for you to go up to 3 decimal places and then round it off correct to 2. Both the steps have to be shown one below the other to get the last 1 mark. You cannot take it in rough work column or in your mind up to 3 decimal places and then round and put the final answer. No. Now here it is there, so I presume you know the rounding off techniques. So correct to 2, so we'll look, this will be 0.26 and this will be minus 2.26. When all these 4 answers are correct, you will get the last 1 mark. No need to write again solution set, you can safely leave it at this stage. Question 5. Solve for x. X minus 18 upon x equaling 6. Here you are asked to report your answer correct to 2 significant figures. Correct to 2 significant figures. Now we will have to simplify this equation, get it in the standard form, and then only we can proceed. Take the LCM x, this will be x square minus 18 is equaling 6. X square minus 18 is equaling 6x. So x square minus 6x minus 18 is 0. Now the equation has been arranged in the standard form. Power 2, then the power of x1 and then the power disappears. So here compare it with the standard form. A will be 1. A is the coefficient of the square term. Which is the middle term? Minus 6x. So what is the coefficient of x? Minus 6. What is C? Minus 18. As usual, apply the formula, but here we will write now x equaling minus b plus or minus root of b square minus 4ac, the whole divided by 2a. Remember the tip, square root sign and the upon sign properly stretched. Now let us substitute. 1 minus comes because of the formula. B itself is minus 6. So minus of minus 6 plus or minus root of b square minus 4ac, the whole divided by 2a. What is a? 1. So this step will fetch you 1 mark. So minus into minus plus, plus or minus square root of 36, 4 into 1 into 18. How much? 72. Negative into negative, positive. So plus 72. The whole divided by 2. So 6 plus or minus, add this. Do not try to use the square root on 36. Square root will not operate on 36 because there is a plus sign. Yes, if there was a multiplication sign, then the square root would have operated on both the terms independently, no problem. But not when there is plus or minus. So we'll have to add this. This will come to 108, the whole divided by 2. Now again we can use splitting here. So it will be 6 plus or minus 36 into 3. That is 108. Good splitting. 3 cannot be further split and 3 is not a perfect square. Upon 2. So 6 plus or minus 6 root 3. Square root of 36, 6 and then into root 3 divided by 2. Now root 2 and root 3, it is good if you learn by heart. Root 2 is 1.414 and root 3 will be 1.732. Nevertheless, you can refer to these tables again. Which page? Page 28, powers and factorials. You will get the square root of 3. So no need to worry in case you have forgotten also. Okay, now we can do double division here to make calculations easy. See, we can put the square root of 3 as 1.732, multiply by 6, and then perform this addition subtraction. But if we use little power of observation, 2 divides this 6, 2 also divides here. So why not go like this? 6 divided by 2 plus or minus 6 root 3 upon 2, just to simplify the calculations. So this will be 3 plus or minus 3 root 3. Now we can take 3 common. If you want, it's fine. Otherwise, it's a small number. So we can just go like that also. So it is 3 plus, sorry. So it will be 3 plus 3 root 3 or 3 minus 3 root 3. So 3 plus 3 into root of 3, how much? 1.732. And here 3 minus 3 into 1.732. So this will be 3 plus, let us multiply 1.732 into 3. 3 2s are 6, 9, 5.196. This is 3 plus 5.196 or 3 minus 5.196. Comfortable till here? This addition is okay, you can do it mentally. 8.196. Here perform the subtraction. Perform the subtraction and see. 5.196 minus 3 minus 2.196. Sign we will have to adjust logically, but perform the subtraction and see, because at times you will get tricked in the numbers. I'll give you some example a little later. Problem is not yet over. We have to give our answer correct to 2 significant figures. You are already aware significant figures. So now here this is the first significant figure, second significant figure, and then this is a third one. So this is 9, so this will increase. It will become 8.2. Do not write 8.20. 8.20 will have 3 significant figures, while as the question says correct to 2 significant figures. So your final answer should contain only 2 significant figures. And here it will be minus 2, first significant figure, second significant figure, third significant figure. This will increase minus 2.2. So the answer is 8.2 or minus 2.2. Kindly note, all these 4 answers have to be shown in fair to fetch the final 1 mark. A little modification. What if it was said, give your answer correct to 2 decimal places? Instead of significant figures, it was said, give your answer correct to 2 decimal places. Then 1 decimal place, 2 decimal place, 3 decimal place. And this would have become 1 more. So this would have become 10. Then carry forward. So it will become 8.20. Note this. If they would have said, give your answer correct to 2 decimal places, then this would have been 8.20. Here also first decimal place, second decimal place, third decimal place. So 9 will become 10 and 1 carry forward. So then this would have become minus 2.20. So see how the answers differ. Yes, value wise it is the same, but reporting there is a significant difference. So the answer would be 8.20 and minus 2.20 if we were asked to report the answer correct to 2 dp, or if instruction was not given, then standing instruction is give your answer correct to 2 dp. But here it was correct to two significant figures, so we had to write 8.2 and minus 2.2. Question 6. Consider y square minus 6 is equaling 2 root 2y. The question is solve for y. Use power of observation. Do not be in a hurry. Root 2 देखा तो 1.414 डाल दिया. No. That all we will do it in the end. Just imagine if you put 1.414 here, root 2, and then multiply by 2 and then deal what it will become. First, arrange the equation in the standard form. This is not arranged in the standard form. So y square, get the y term in the middle, minus 2 root 2y minus 6 is 0. Arranging the equation in the standard form is the most important, else all the subsequent things go wrong. So now this is square term, then the power of y is 1, then minus 6 equaling 0. Okay, now we'll go a little quick because you have already got a good foundation in that. A will be 1, A is the coefficient of the square term. B will be minus 2 root 2, not 2 root 2. C will be minus 6. Now we use the formula y equal to, what does the formula give us? It gives us the roots of the equation. So y is equaling minus b plus or minus square root of b square minus 4ac the whole divided by 2a. Bring down the minus sign. B itself is negative. So minus of minus 2 root 2 plus or minus square root of b square minus 4ac. So a is 1 is simple substitution. The whole divided by 2a. Comfortable till here? So now let's simplify this. No need to write y equal to again and again. Once you wrote y equal to, fine. Then just carry forward from there. So 2 root 2 plus or minus 2 root 2 the whole square. How much? 2 root 2 into 2 root 2. So that will be 8. And of course when you square anything, it is always positive. This will become minus into minus plus 4 into 1, 4 into 6, 24. Minus into minus plus. The whole divided by 2. This will be 2 root 2 plus or minus square root of 32. The whole divided by 2. Now we can directly find the square root of 32 from this book, Miller and Paul, Powers and Factorials. But we realize that we can split. See, if it was not splittable, you can directly find. Say, square root of 57, you can directly find from Miller and Paul. Square root of 85 can be found directly from Miller and Paul. But here, there is a good scope for splitting and making things easier. So 2 root 2 plus or minus root of 16 into 2 upon 2. So this will be 2 root 2. This will be how much now? Plus or minus 4 root 2 upon 2. So now two possibilities. 2 root 2 plus 4 root 2 the whole divided by 2, or 2 root 2 minus 4 root 2 the whole divided by 2. Wait, do not put the value of root 2 here. There is scope for addition. In the end we will see what is to be done. This will be 6 root 2, radicals. 2 root 2 plus 4 root 2, 6 root 2 upon 2. This side it will be minus 2 root 2 upon 2. We can cancel 6 and 2. So this will be 3 root 2. Here 2 and 2 nicely gets cancelled. So it will be minus of root 2. Be careful, it is not root of minus 2. It is minus root of 2. Now substitute 3 into 1.414. Square root of 2 is 1.414. We have it by heart, or you can use the Miller and Paul table, powers and factorials page. And here it is minus 1.414 nicely. How much is 1.414 into 3? Let us multiply and see. 1.414 into 3. 3 4s are 12. 3 4s are 12. 4.242. 4.242 minus 1.414. Now here, was the degree of accuracy specified for the answer? No. So what should we do? Go up to 3 decimal places and round it off correct to 2. So 3 decimal places, so we have already taken. Now let us round it off. This will be 4.24 and this will be minus 1.41. Leave the answer here, absolutely no problem. Comfortable till this stage? One final sum on formula. We'll just give the outline and then you can take it from there. Y plus 1 upon y is 3.5. Solve for y. So we'll have to take LCM. This will be y square plus 1. Now 3.5, be careful, you can't deal with these decimal numbers while substituting, very difficult. So the whole idea is to put it as 35 upon 10. There is scope for further simplification. 5 7s are, 5 2s are. So this will be 7 by 2. Now you can cross multiply. So 2y square plus 2 is equaling 7y. Mind you, the equation is not in the standard form. We will have to bring it in the standard form. So 2y square minus 7y plus 2 equaling 0. You want to try by factorization? Try. It is not possible. Coefficient of y square how much? 2. Constant term how much? 2. 2 into 2, 4. Try splitting as two numbers with any signs in such a way that when you add these two, you get minus 7, but when you multiply, you get 4. Possible? Ponder it over. No. So we have to go by formula. Comparing the equation with ax square plus bx plus c equaling 0. No need to write that step in the exam. We can simply show a is 2. A is the coefficient of the square terms. B is minus 7 and C will be, B will be the coefficient of y, that is minus 7 and not 7, and C will be 2. Having sorted this out, now is the matter of simple substitution. So we will write y equal to, because we are finding the value of y, so minus b plus or minus square root of b square minus 4ac the whole divided by 2a. B, this minus comes down. What is b? B is minus 7 plus or minus, now simple substitution, minus 4ac. What is a? 2. What is c? Also 2. The whole divided by 2a. A is also 2. Okay. Now just work out this it will be 7 plus or minus square root of 49 plus 2 into 2, 4, 4 into 4, 16 minus 16 divided by 4. We can go on writing equal to if you want, otherwise if you just show it in first two steps is more than enough. Just go on working out. No marks are lost. Okay. Don't let the square root operate on 49 and 16 separately. There is a minus sign. So square root will not operate like that. You will have to actually first subtract and then let the square root operate. So 49 minus 16. How much? 33. So square root of 33. The whole divided by 4. From here onwards now you can take it. Square root of 33, this we can't split. We can write 3 into 11. But no use because 3 is not a perfect square, 11 is not a perfect square. So we will have to directly find square root of 33 from Miller and Paul. Here it is. It is 5.745. 5.745 divided by 4. Now same routine, two possibilities. 7 plus 5.745 upon 4, or the other possibility is 7 minus 5.745 upon 4. This will be 12.745 upon 4. Take care in this subtraction. You may feel, oh, 7 minus 5.745. So it will be 2.745. At the outset, that thought may come to your mind. Let us see. As I had warned you before, subtractions, you actually work it out and see what it comes. Now this will be 7.000 minus 5.745. 5. This will be 5. This will be 2. And this will be 1. So here, this was the reason why I specially took this sum, because of the nature of the numbers. These kind of situations very often come in the board exam where you feel, oh, we can subtract orally and that oral goes wrong. So better actually see the subtraction. It comes 1.255 and not 2.745 what it appears at the outset. What is the sign? Bigger number, smaller number. So, okay, this is going to be positive. So, this will be 1.255 divided by 4. Always take care of the signs. Whenever you are doing addition, subtraction, fine to get the answer. But signs you have to adjust on your own. Now, I leave it to you. You divide this, go up to 3 decimal places. Here also go up to 3 decimal places and show it in fair. And then round off your answer correct to 2 decimal places. Fine with this sum? So, up to this point of time we have studied quadratic equations, how to solve it by factorization, how to solve it by formula. We saw several good examples. Okay, some typical sums were covered. Now let us come to the final thing of this topic, which is equally important, which was newly added in the syllabus in the year 2008, and it is very much still there. Nature of roots. Understand the difference between finding the roots and finding the nature of roots. They are different things. Say you take a blue litmus paper, put it in some container and pour a liquid on it, pour some liquid on it. If you observe that the blue litmus paper has turned red, what do you conclude? We conclude that that solution which you have poured on the litmus paper is an acid. But which acid? That we don't know. For that, further tests have to be done. So this is like to find the nature of roots. So here we found the nature of liquid. How? With the help of blue litmus paper test, blue turning red. So the liquid should be acidic. But which acid? What is the concentration? We would not know by that test. So here we are just trying to find the nature of roots of the quadratic equation. So there are three broad conditions which we have in standard 10th. In standard 11th and 12th, you would have still deeper conditions, but we are not having those. So there are three set conditions. Let us see them one by one. If b square minus 4ac is 0, if b square minus 4 is, now where are we? On nature of roots. So if b square minus 4ac is 0, then roots are real and equal. I will explain this a little later. If b square minus 4ac is greater than 0, open mouth is towards b square minus 4ac. So open mouth means greater. If b square minus 4ac is greater than 0, then roots are real and unequal. Unequal is also, other word is distinct, means different, unequal. Like say one root could be 7, other root could be 9. So they are unequal. So roots, if b square minus 4ac is greater than 0, then roots are real and unequal. So unequal can also be called as distinct. Keep this word in mind. If b square minus 4ac is less than 0, the closed mouth is towards b square minus 4ac, then roots are not real. In the bracket, imaginary. Now, due to paucity of time, I cannot explain you the reasoning behind all these conditions. But if you recollect your formula, minus b plus or minus root of b square minus 4ac the whole upon 2a, this is connected to that. Okay, if you try and substitute, you will figure out the reasoning behind these conditions. It is quite simple, but we will just come to the point and solve some sums based on the same thing. So these are the three conditions. If b square minus 4ac turns out to be 0, then we can say roots are real and equal. If b square minus 4ac is greater than 0, then roots are real and unequal. Unequal also can be called as distinct. And if b square minus 4ac is less than 0, then the roots are not real, imaginary. Okay. Now, real numbers means any number you take is a real number. Okay, except for numbers something like square root of minus 9. Try finding square root of minus 9. Okay, if I say it is 3, no, 3 square is 9. So square root of minus 9 cannot be 3. Somebody would say minus 3. Let us see, minus 3 the whole square 9. How can I say square root of minus 9 is then minus 3? Not possible. So this will be 3 small I. Now all these things you will study in 11th standard, the complex numbers and all. So basically b square minus 4ac is lesser than 0, and lesser than 0 means negative, then the roots are not real. Roots do exist. Roots do exist, but they do not fit into our real number system. So we say roots are not real. We cannot say roots don't exist, but roots are not real in nature, and so they are imaginary roots, but they do exist. And you will be taught how to find such roots of such equation in higher classes. Find the nature of roots of x square plus x plus 1 equaling 0. Find the nature of roots. You can have such questions for 2 marks. Or they may say, without solving, comment upon the nature of the roots. Please note, when they say without solving, it does not mean that you do it in your mind. No. Without solving means you are not expected to use the formula or to solve the full sum, then look at the final answer and say, oh, now I know the nature. What is the sense? If you are solving the whole equation, getting the 2 roots and then giving the nature of roots, no point. Without solving, we should be able to judge. So ultimately, without solving the equation means by using b square minus 4ac only and not that full formula. So b square minus 4ac is also known as the discriminant, or is also known as the discriminant, with the help of which you can distinguish between the roots. So here's solution. Okay, we are not finding the roots of the equation. Take care. We are finding the nature of the roots. How would we find the roots of this equation? Simple. Find the value of ABC, use the big formula. Minus b plus or minus root of b square minus 4ac the whole divided by 2a. But now the question is something different. It says find the nature of roots. So what will we do? We will find the discriminant only. Okay, before we go into the discriminant, is this equation in the standard form? Yes. Okay. If no, please remember to arrange the equation in the standard form. Here a will be 1. A is the coefficient of x square. B would be 1 because it is x, so it is like 1x. C would be also 1. What if this was x square minus x, suppose? Then a would be 1, b would be minus 1, c would again be 1. Okay. So let's compute b square minus 4ac. This will be 1 square minus 4 into 1 into 1. So 1 minus 4, that is minus 3, which is lesser than 0. Which is lesser than 0. So, recall those 3 conditions. If b square minus 4ac is less than 0 means what? Negative, which this is. So, what can we say about the roots? So, roots are not real, in the bracket imaginary. Okay with this? So such sums can come for 2 marks, easy, on nature of roots. Question 2, advanced version. X square plus twice of m minus 1 into x plus m plus 5 equaling 0 has real and equal roots. Find m. This had come in one of the board exams in one of the years. I don't remember, maybe 2012 or 13. Okay. So x square plus twice of m minus 1 into x plus m plus 5 equaling 0 has real and equal roots. Find m. Here we have to use reverse logic. The difference between the previous sum and this sum is, in the previous sum you are asked to find the nature of the roots. Here the nature of roots is already given. You have to reverse work out m. So first let us see if the equation is arranged in the proper form. X square, okay, power is 2, then power of x is 1 and then the power disappears. This is very important. Slight twist in the question and you just directly solve A, B, C, boom, everything goes wrong. Now here A is 1, B is twice of m minus 1. Whatever is sticking to x, what is sticking to x? Twice of m minus 1 and the sign is positive. So okay, what will be C? The constant term, will it be m? Will it be 5 or will it be m plus 5? Naturally it will be m plus 5, that's a constant term. Now, as the roots are real and equal, as the roots are, you can write that statement better, as the roots are given to be real and equal, b square minus 4ac is bound to be 0. The roots are already real and equal, and which was the condition? If b square minus 4ac is 0, the roots are real and equal. So reverse is also true. If the roots are given to be real and equal, b square minus 4ac will be 0. Now simple substitution, twice of m minus 1 the whole square minus 4 into a into c is equaling 0. So it will be 2m minus 2 the whole square, 4 into 1 4 and then multiplied by this. Now let's work on this. It is a minus b the whole square. So 4m square plus 4, first term into second term into 2. So minus 8m minus 4m minus 20 equaling 0. What can be simplified? 4m square minus 12m minus 16 equaling 0. Let's reduce this equation to make things easier. We can divide each and every term by 4. Ultimately, what are we doing? Trying to find the value of m. In the process, we have got a nice quadratic equation which we will have to now solve it. So this will be m square minus 3m minus 4 is 0. We can factorize. If you want, you can use the formula also, no problem. But factorization is little quick. Let's see if it works. M square is 1. 1 into minus 4. So it is minus 4. 1 and minus 4. 1 minus 4 is minus 3. 1 into minus 4 is minus 4. So both the conditions are taken care of. So it will be m square plus m minus 4m minus 4 is 0. M into m plus 1 minus 4 into m plus 1 is 0. So now in this and this you have m plus 1 common. So m plus product of two numbers is 0. So m plus 1 is 0 or m minus 4 is 0. So m is either minus 1 or m is 4. So we have successfully found the value of m under the given conditions. Find the value of k. Find the value of k if 3x square minus 6x plus k equaling 0 has distinct and real roots. Find the value of k if 3x square minus 6x plus k equaling 0 has distinct and real roots. Recall the three conditions. If b square minus 4ac is greater than 0, then the roots would be real and unequal. Unequal is also called distinct. This is reverse of that. Is this equation in the standard form? Yes. Okay. So here A will be 3, B will be -6 and C will be K. Note that the roots, nature of the roots is already given to you. So what can we say now? It is distinct and real. So can't we say that b square minus 4ac will be greater than 0? Will it be greater than or equal to? No. Because they said the root, when it will be equal to 0? When it is equal. But here it is not equal. Okay, here the roots are not given to be equal. The roots are in fact distinct and real. So then b square minus 4ac greater than 0 is our conclusion. So it will be -6. Note the difference between this question and question number 1 what we covered under the category of nature of roots. There we had to find the nature. So we could never say b square minus 4ac is equal to 0 or is it greater than 0, because that is what we have to find and then decide. Here roots are already given, the nature of roots is already given. So we need to use that condition. So b square minus 4ac will be greater than 0. So -6 square minus 4 into 3 into k is greater than 0. So 36 minus 12k greater than 0. Now you very well know in equations, you have done this topic. So we will use that. Minus 12k will be greater than minus 36, transposing it here. Two negatives are cancelling. So inequality will reverse. So k will be less than. Here open mouth is towards k. Now the closed mouth will come towards k and minus 12 will go down. So k is less than 3. So here for all values of k lesser than 3, for all values of k lesser than 3, this equation will always give you distinct and real roots. Given that two is a root of the equation three x square minus x plus 1 into p equaling 0. So 2 is given to be a root of the equation, and that the equation px square plus 9 minus qx equaling 0 has equal roots. Find P and Q. Is the question clear? Given that 2 is the root of the equation 3x square minus of x plus 1 into p equaling 0, and that some other equation has equal roots, but then this p and this p would definitely be the same, and this is qx. Okay, be careful while writing 9 and q. 9 will come like this, q will come like this. Find p and q. Okay. Now that 2 is given to be a root of the equation, what will happen? It is bound to satisfy the equation. So this is a quadratic in what? It's a quadratic in x, and we have to find p and q. So we will substitute 3 into 2 square minus of 2 plus 1 into p equaling 0. After substitution, it will be definitely be satisfied the equation. So 12 minus 3p is 0 minus 3p will be minus 12, p would be 4. So we have found the value of p. Now what remains is only the value of q. So let's first put p in this new equation. So we will get 4x square because p is 4 plus 9 minus qx equaling 0. What remains is to find the value of q. But first put the equation in the standard form. So 4x square minus qx plus 9 is 0. This was not in the standard form. First the square term, then the power of x1, and then the power disappears. Note that this equation has equal roots. Find p and q. So here a will be 4, b will be q? No, b will be minus q. C would be 9. Since this equation has already equal roots, the nature is already known. So what can we conclude? B square minus 4ac will naturally be 0. Now substitute minus q square minus 4 into 4 into 9 equaling 0. So this will become q square, minus when you square. Q square minus 4 into 4, 16. 4 into 4, 16. 16 into 9, 144. This minus you bring it down, okay. So q square will be 144. I'm coming on this side now. Q square is 144. So q will be square root of 144, which is plus or minus 12. So here both answers will work. So q can either be 12 or q can also be minus 12. So now we have completed this topic, quadratic equations. We studied type 1 how to factorize, type 2 how to solve it by formula, and remember in the exam they will not tell you solve by formula, not necessarily. You will have to judge it, but you can easily judge that if it is not factorizable, go by formula. Even if it is factorizable and if you still want to use the formula, no problem. Degree of accuracy of the answer, if not specified in the question, go up to 3 dp, round off correct to 2 dp, show all the steps in fair. Remember to use these books for square root, powers and factorial. Square root of a 3-digit number, remember to split and accordingly then make it into a 2-digit number and then use this. And then finally we studied nature of roots, in which we studied 3 conditions and we solved few sums on them. Remember, equation should always be in the standard form. Thank you and wish you all the best.